Okay, so hopefully you're watching this after you've done your Desmos task and you have realized that when the leading coefficient of a quadratic, when it's greater than 0, that's when we have it pointing upwards, and we call that convex. Some books call it concave up. Not a fan of that. And when it's negative, then that's when we say it is concave, right? I like to think bear in the cave, concave. All right, so we've already seen a quadratic expressed in what we call general form, so ax squared plus bx plus c. But what we want to do here is realize that when we can express it in this form, it's actually called the vertex form, because when we have it like that, we can actually then say, well, the vertex will be h, k. Notice we reverse the h value and the k stays the same. So as an example, again, after you've done your Desmos task from the OneNote, if we had something like y equals minus 7x plus 1 squared take 3, we know that the vertex of this will be, sorry, look at the 1. And because that's a plus 1, we now reverse the sign, so it's minus 1, and we keep the k value, which is minus 3. The 7 here does nothing to the value or the position of the vertex. All that does is the fact that we've got a large number in 7 means that it's going to be really skinny, and the negative means that it will be reflected in the x-axis. Okay, so all of this we should have discovered when we were doing that task from Desmos. All right, so what we want to do now is match up the equations with the graphs. And if you notice, there's 2 pairs, or 3 pairs that have the same vertex, and we just have to figure out which one. So you can either look at the graphs and suss the vertex and go to the equations, or you could look at the equations and go to the graph. So as an example, let's start with the first one. We've got A, and we can see just from the equation that the vertex is going to be minus 2, minus 3. Okay, so we're looking over here, minus 2, minus 3. So it's one of these two. How do we know which one it is? Well, let's see if there's another one. So we're looking for another x plus 2. Here it is here. So this one also has a vertex of minus 2, minus 3. But which one is which? Well, we look at the coefficient, the a value. So for this one, a is minus 1. And for this one, a is minus a half. Now we know the minus has done its bit because it means it is concave. Concave. And then we sort of ignore that negative, and we have to go, the one that's going to have the bigger number, that is going to be the steeper one. So 1, I hope you agree with me, is bigger than just a half. So that means f has to be the steeper equation, which means in this case it's a is 1, so that means that's f. Which means this one, oh, look at that, E and E. So go through, do the other 2 pairs and see how it goes. So stop the video and then finish and come back in. The next thing that I'm going to ask you to do is a skill that we've already established, and that is completing the square. And we're going to use that to express a quadratic that might be in general form. We want to now put it in vertex form. And again, the reason for that is because if we have it in vertex form, we can then proudly state and confidently state what the vertex is. It would be HK. Okay, so let's recall how we did this. We look at that bit there and we go, all right. Oops, my pen is not playing nicely at the moment. And we halve the 2. Okay. Sorry, now I've lost my recording a bit. And we're back. So halve the 2 and we get that's plus 1. We're going to realize that when we expand this, we will get an x squared, we will get a 2x, but we will also get the 1 squared, which is 1. So we've technically added 1 to this side. Now, when we were doing the solving, what we did was we would add 1 to the other side. But because the other side is y, we don't want to do that. So to get rid of that plus 1 from the right-hand side, we are also now going to minus 1. And then we keep the plus 5. So what we now have is we have x plus 1 minus 1 plus 5 is positive 4, and we can now confidently say that the vertex would have to be minus 1, 4. And that's it. So let's try one more. Okay, so another one like so. We're going to underline that bit there like we always do. We are going to say y equals. I like to put the y equals because then we're not tempted to add something to the other side thinking it's 0, so always put the y there. We look at the 8, we're going to halve that, so x plus 4. And remember, when we now expand a perfect square, we'll get the 8x squared. We'll get the x squared, we'll get the plus 8x, but we're also adding in 4 squared. So we have to take off 4 squared, otherwise known as 16. So we simplify this, x plus 4 squared, we've got minus 16 plus 6. Now do make sure, I know I made a big deal when we're doing the quadratic formula, that when we have like minus 5 squared, that is not the same as minus 5 squared. They do not equal, right? Minus 5 squared is 25. Minus 5 squared, that is minus 25. So two different things. Now in this case, I know some people get that in their head, but this is definitely the second version. So this will be minus 16 plus 6, which gives me x plus 4. Minus 6 plus 6 is minus 10. And like we did last time, we can now say my vertex is going to be minus 4, minus 10. Okay, let's do one more. I know you're all asking, what happens if it's odd? What happens if it's a negative? So let's combine that all in one. All right, that's the bit we're looking at. We're going to say, just like we did before, we're going to halve this, so that's minus 5 over 2. When we expand this, yes, we get the x squared, yes, we get the minus 5, but we've also, technically we have added in 5 over 2 squared when we expand it, right? So now we have to subtract 5 over 2 squared, and we've still got that, plus 2. You can now go to your trusty calculator, and hopefully it tells you the same thing that mine does, 17 over 4. And to get rid of the squared, we don't need to get rid of the squared because we've now got it in the form that we want, and so therefore our vertex is going to be 5 over 2 minus 17 over 4. Right, so you keep the sign and everything. Now let's just hang on to that for a minute, and we would like to confirm this using our graphics calculator.